worse, tougher time assigned to recruit the student. No, the only popular subject in engineering is the civil engineering, architecture. They are more popular because we still need to build a building. But other engineering like a triple E, even computer science is very difficult because, relatively speaking, is the student consider computer science kind of a very tough job. They have to work not 10 hours a day, they have 12 hours a day. It's very tough, very tough. So you more prefer to go to the company than you only to work from 9 to 5.
It looks like astronomy going to grow.
Yeah, I guess that there will be more students and more staff, but it cannot be a very big community because it's basically restricted by the job market. But on the other hand, our research actually generate some impact in the research in our field. If you look at the paper we publish, we usually quite good. But on the other hand, how can you do in a commercial city? And the government will not give you specific support. You just try your best.
This is already excellent.
Yeah. Within the restriction, we are doing okay. Yes, we're doing okay.
There are some methods opposed to the amateur astronomers, they say. For example, there is the richest gentleman in Asia is called Yikashin.
Oh,
and I propose to the amateur astronomers to ask for support for him. And if they discover a new planet, they will name it after this gentleman. This gentleman may have a planet or a star in the sky, so it will be very much interesting.
The minor kind of thing is
the major planet.
But we do not have that kind of thing. Oh, but we do have a so-called salt price in astronomy, and which is give $1 million US.
What do you call the price?
Salt price. SHAW. It's called salt price. Basically, we watch three fields: astronomy, mathematics, and biological and medicines. Okay, each area is $1 million US.
Yeah. Choice famous.
It's a very famous salt. Yeah. He gave money to. He made a lot of donation. I think he made almost $1 billion. Is that US? Perhaps not $1 billion US. At least $100 million US to many different places. He's rich. He's over 100 years old. You know, he's 100 years old this year.
Oh, okay.
He's still healthy. And
Shaw Brother is very.
oh yeah, Shaw Brother is also famous in East Asia.
Yeah.
It's a Shaw Brother. They started in Singapore, and they make movie in the beginning.
So,
yes. So in fact, I have prepared 3 talks. Basically, this one is rather non-technical. I have also one which is semi-technical and another one which is more technical. So I don't know which is the level of interest.
yeah,
in this kind of talks.
I think the general background.
Okay, so I will start with this completely non-technical talk, and perhaps we may also continue with some other talks. So the title of this talk is Einstein's biggest blunder. And what I will, the content of my talk is as follows. So in the last 10 years, one of the most active fields of research in science became cosmology. Cosmology is today a very popular field of research. And a lot of funding and a lot of effort is invested in this field. So first of all, I will try to give an answer to the question, what is cosmology? Then, because cosmology is in fact a part of physics, a part of science, it is based on some facts. And I will review the basic observational facts of cosmology. But because we have a set of observations, we also need a theoretical basis to understand cosmology. And this theoretical basis is given by the theory of the relativity. So I very briefly will describe the fundamental ideas of the theory of the relativity. Then I will review the present day standard model of cosmology, which is based on the theory of relativity, and it is called the relativistic cosmology. And finally, I will devote some time in discussing what was in fact the last major discovery of the 20th century. You know that the 20th century was one of the most important centuries in the history of physics. There were many, many amazing discoveries like quantum theory, special relativity, general relativity, etc. And the 20th century ended in fact with another major discovery, the last major discovery of the 20th century, which is the so-called accelerating universe. A very amazing discovery which is still at the center of the scientific research today. And I will briefly conclude about these the issues we have discussed. So first of all, what is cosmology? Cosmology has a very simple definition, in fact. It is the study of the universe, of the entire universe. So cosmology regards the universe as a kind of atom. A single atom, this is the universe with all its complexity. Of course, being a kind of atom, the entire universe, it has some components. So the next issue in cosmology is to discuss the components of the universe. Then how the universe was formed. The central issue in cosmology is the formation of the universe. What was the evolution of the universe after it was formed? And especially recently, the future of the universe also became a very hot topic of debate. So what is the future of the universe is again a fundamental issue in cosmology. Now, as being a science, in fact, it may be a part of physics or a part of astronomy, this is perhaps a matter of debate, but anyway, cosmology uses scientific methods. And it is based, as all physical sciences, on observations and mathematical modeling. So modern cosmology is in fact a very recent science. It originated around 80 years ago. It's the youngest science, it's the youngest branch of the physics, I may say. And it's, in fact, it's the first major observation that triggered, in fact, the development of cosmology was the discovery of the expansion of the universe. Now, this discovery started around 90 years ago. As I said, cosmology is a very, very young science. And everything started when an astronomer, in fact, called Slipher, was able to detect the Doppler shift of the spectral lines. And he was able to do this by around 1910, 1920. So you know very well the Doppler effect. This means that the light, the frequency or the wavelengths of the light from moving objects is different from the wavelengths of the light emitted by objects that are at rest. So in fact, if we have two objects which are at rest with respect to each other, we measure a spectral line, which is, let's say, this one. Now, if one of the objects, in fact, is moving away from this object which is still at rest, then in fact the spectral line will be shifted. And if the object moves away, the shift of this line will be toward the red part of the spectrum. Now, if the object is moving towards the observer, we will have a redshift of the same line toward the blue part of the spectrum.